All right, we can think about fractions using a linear model with these cuisenaire rods. And so it's really important that we understand the relationship that the cuisenaire rods have to one another. So this image to the left stays on this website, which is nice because I can see how these rods are related to one another. And so if we want to think about fractions in a linear model, that means that they're in a line. So there's like a starting point, an ending point. You might think of a number line. You might think of a length or a distance that these rods are measuring. This is how we think of, or how we can relate linear models to real world applications. Okay. And so the way that these cuisenaire rods work is that we can name a rod as one whole, and then we can find the value of the other rods. So, for example, if we start with this red rod and we say that the red rod equals one whole, I can name the value of this white rod as 1/2 because it takes two of them to make the whole. Okay. But if I were to say that this green rod equals one whole, okay, the value of the white rod is now going to be 1/3 because it takes three of them to make one whole. Now that we understand how the value of these rods can change, let's look at one of the other rods. I'm going to use this dark green rod, and I'm going to say this dark green rod equals one whole. I get to name that value because rods do not have numbers on them. They do not say that this has to equal a certain value or an amount. This is why we like to use the cuisenaire rods, because we can make it whatever we want. And it will help children see how fractions are really dependent on the size or the value of one whole. Okay, so if the green rod equals one whole, that is obviously going to change the value of my white rod. Okay, I need to see how many white rods I can fit into one whole. That is 3, 4, 5, and 6. Okay, so the value of the white rod would be 1/6 of the green rod. Okay, let's look at the value of the red rod. Okay, I want to see how many red rods I can fit in to the length of my green rod. That is 2, 3. Okay, because 3 red rods fit into a green rod, that means the value of the red rod is 1/3 of the green rod. All right, and then finally, I want to look at the light green rod and see how many light green rods can I fit into a dark green rod. 2 of them can fit, so the value of the dark green rod would be 1/2. Okay. Now I can keep going. I can look at the purple rod as well. Okay. It's a little tricky because I can't even fit 2 of those in there. I can only fit 1 full purple rod into my dark green rod. But I can use the values of the other rods, and it's really nice to see where these line up with the other rods. And I can see that the purple rod lines up very nicely with 2 of my red rods or 4 of my white rods. And so I can use the values of those rods to help me figure out the value of the purple rod. So because the white rod is 1/6 of my whole, the purple rod is 1/6, 2/6, 3/6, 4/6 of my whole. Okay, so I could look at it using the value of the white rod, or if I wanted to scooch it down and look at the value of the red rod, I could say The red rod is 1/3, 2/3, 3/3, and it lines up perfectly, the purple rod lines up perfectly with 2/3 of those red rods. So its value is equivalent to 2/3 as well, okay? This can help children see that 4/6 is the same as 2/3, and therefore my purple rod can be described as 2/3 of the green rod or 4/6 of the green rod. All right, and then finally we have the yellow rod. And again, I want to use the rods that I already know, okay, and see where it lines up. It doesn't line up with the purple rod, not the green rods, not the red rods, but it will line up with these white rods. It lines up with 1/6, 2/6, 3/6, 4/6, 5/6. Okay, that means it is equivalent to that same value. So the yellow rod would be 5/6 of my green rod.